Let's learn some basic concepts from chemical thermodynamics. Chemical thermodynamics is the branch of chemistry which deals with the study of energy changes which are taking place in any chemical or physical processes. We know different chemical and physical processes. One very simple example of physical process is ice when heated is converted into liquid water. This is a simple physical process where there is only change in the state of that water takes place. Though it is a simple physical process, it is accompanying with some changes in the energy. Because here in this process we have to add energy, we have to provide energy to the ice. Then it is converted into liquid water. We can observe the another chemical reaction which is given. Carbon when reacts with oxygen, it is converted into carbon dioxide. It is a combustion process. So we can say oxidation process where carbon reacts with oxygen to form carbon dioxide. Though it is a chemical process, it is also accompanying with the exchange of energy or changes in the energy. So we can understand from these different examples of physical and chemical processes that every physical and chemical process is having some changes in the energy or accompanying with the energy changes, and therefore it is very important to understand the energy changes which are taking place in every physical or chemical processes. So in thermodynamics we are going to learn about the energy changes taking place in the physical and chemical transformations or processes. Thermodynamics is a branch of chemistry which deals with the energy changes which are taking place in the physical and chemical processes or transformations. Though thermodynamics is related with the energy changes taking place in physical and chemical processes or transformation, it will not related with or it is not related with the rate of the chemical process. It will not give any idea about the rate or rate of the chemical process. Also, you will not get any idea about the mechanism of the chemical or physical process by studying this thermodynamics. Only thermodynamics gives us idea about the energy changes taking place or accompanying with the physical and chemical transformations. Now let's learn some basic concepts used in thermodynamics. First of all, we should understand what is system and surrounding. You can observe this diagram. Here in this diagram, in the universe, it is a diagram of just consider it as diagram like universe is very large actually, but here we are representing this universe, system and surrounding with this help of diagram. Now as we know that universe is very large, and in this universe the system which is very small part of the universe. Now this is diagrammatic representation, but I will give you one example. If you have any chemical process which is going on, and if you have a beaker, in that beaker you have some sort of chemical process which is going on, and you are observing that beaker. So here in this particular situation, the beaker containing some chemical reaction is a system like this. So this is system which is a part of universe, very small part of universe. So like that, the beaker which is having chemical process which is going on inside the beaker is a system which is very small as compared to the whole universe. But you are observing that chemical process which is going on in that beaker, and that's why it is called as system. So system is a part of universe which is under thermodynamic consideration. The meaning of thermodynamic consideration is you are observing energy changes which are taking place in the system. That is called as thermodynamic consideration. You are observing the changes of energy which are taking place in the system. So system is a part of universe which is under thermodynamic consideration. Whereas surrounding is the part other than the system which is also part of universe, but where the observations are made. The place where you're standing and observing that same beaker containing the chemical process, that part other than the system is called as surrounding. So from this we understood that system is a part of universe which is under thermodynamic consideration or investigation, whereas surrounding all other parts of the universe outside the system. So it may be cylinder, room where you're standing and observing any chemical process, physical process, and others. These are called as surroundings. Now let's learn types of system. Observe the diagram. In this diagram, first A diagram is given, that is open system. Here we can observe it contains or it shows a cup containing some hot substance inside the cup. Just consider hot tea or coffee is placed in that cup. So when we observe such cup containing hot tea or coffee, we can observe that the vapors are continuously escaping into the atmosphere. And after 5 or 10 minutes, if you keep that cup open like this for a longer time, then the matter or the substance which is present inside, that is hot tea or coffee, which cools down after 5 or 10 minutes. So this means that the energy which was initially present in that substance or cup, which is a system, is escaped or exchanged with the surrounding. It is exchanged with the surrounding. It escapes into the surrounding, and that's why it cools down after 5 or 10 minutes. So this a cup containing hot tea or coffee is open system. Why it is open system? Because there is exchange, continuous exchange of this matter, means substance. Vapors are nothing but water, water vapors. So it is a matter, substance. And we can say that open system is a system in which there is continuous exchange of heat or energy as well as matter with the surrounding, and that's why it is called as open system. Now another diagram, that is closed system. This is second type of system, that is closed system. Consider same cup containing hot tea or coffee. If you place this saucer on that hot tea or coffee containing cup, and if you close that cup with that saucer, then it is considered as a closed system, because from that closed cup the matter which is present inside the cup cannot escape into the atmosphere because it is closed, but the heat radiations or the energy can be exchanged with the surrounding through this material of the cup or saucer. And that's why though we close this cup containing hot tea or coffee with a saucer, it also cools down after 5 or 10 minutes because the energy is exchanged with the surrounding. But the matter which is present inside cannot escape through this container because it is closed. So we can say that in a closed system only energy can be exchanged with the surrounding, not the matter, and that's why it is called as closed system. Let's observe the third diagram, that is isolated system. Consider that same hot tier coffee is placed, or if you keep that hot tier coffee in a thermos flask. What happens in thermos flask? It keeps the hot substances hot for longer time because it is made with some insulating material which cuts the supply of, or which cuts the outside surrounding from the inside substances or system. So from this diagram or from this observations we can understand that from a thermos flask there is no exchange of energy with the surrounding as well as matter with the surrounding, and that's why the matter or the substance which we keep in that thermos flask remains hot for longer time because energy remains inside the system. It is not coming out from the inner part, or it cannot be exchanged with the surrounding, and that's why it remains hot for longer time. So from this we can understand that in isolated system both matter as well as energy cannot be exchanged with the surrounding. So this is called as isolated system. So these are three different types of system based on the exchange of energy as well as matter with the surrounding, that is open system, closed system and isolated system.